So
yeah, it looks like it's live now.
yeah, we went live.
Hey.
Hello, everyone. Uh, Thank you for joining in. So we are just waiting for a couple of more folks to join, maybe
Okay.
another a minute or two, and then we can kick off this awesome meeting. We are looking forward.
Awesome. Sounds great.
Yeah, I think we can start. We are it's already 5:31.
Okay. Sounds great.
So yeah, before we start, I would like to thank Billy. I mean, it was thank you. I mean, it was difficult to rope him in for this session, but finally we got him. So about Billy, Billy is seasoned Java developer. He also co-organizes Kansas City Java user group, and he works for he works at Oracle, and with his decade-long experience, he finds way he actually helps developers to reduce the tedious work, and then he works on new deployment, how to optimize things. And with the new Java version around, it's very awesome to have him on board to explain us the new features and what is beyond the Java 17. So thanks, Billy, for agreeing to give a session on this, and the stage is all yours.
Great. Thank you very much. And thank you for the invitation to speak here at Hyderabad our Java user group. So yeah, and thanks for the introduction. So that pretty much covers everything about me. So with that said, let's just go ahead and get into Java 17 and beyond. So one thing about me, I guess, is I'm a very demanding speaker. I want you to ask questions. So definitely don't feel like you need to wait until the end of the presentation to ask a question. I'll be monitoring the comments here. I can see them on my screen. So if you have any questions at any point, want me to go into a bit more depth or something, definitely ask them. There's maybe about a 30-second or so delay when it comes to StreamYard. So at least, keep that in mind that if you do ask a question, it may take me a little bit to get to it, both in the delay and then maybe, of course, have to get to the end of maybe an idea I might have. But definitely, like I said, the key thing is don't feel like you need to wait to ask questions till the end. I'll be more than happy to answer them at any point during this presentation. Please reach out to me. You can find me on Twitter at Billy Corando. So reach out, send me a DM, send me a tweet. I'll be happy to answer any questions you have also. And also, you can shoot me an email, billy.corando@oracle.com. Again, I'll be more than happy to answer your questions as well. This might change. I may do some live code samples throughout the presentation, but yeah, we'll take a look at some code examples as well. And also, the most important link is this one. Let's see. Let me see if I can copy that in real quick. Maybe not. I'll get that link both to the organizers and then also post it here in the chat at some point. So that way you have a link to this presentation, and then of course then all the links I'll be mentioning in the presentation as well. So that way you don't necessarily write everything down during it. All right, so what's going to be the agenda for this presentation? First, we're going to look at some of the key new language features. Of course, I'm not going to necessarily cover everything because there's a lot of changes during between particularly Java 11 and Java 17 is what we're going to be particularly focusing on. you'll touch on a little bit some other changes that kind of came between Java 9 and 10 and also 11 itself, just because I know a lot of Java developers out there are still using 8 primarily. So we'll look at that. Also, the new runtime features. Then we'll also look at some deprecation removals and then some just other changes to kind of know about. And then finally, we'll just take a little bit of a peek into the future just to kind of get an idea on where Java is going to be heading in the next few releases. If you do also leave with an intense desire to know more from this presentation, and this is actually what I'll be taking a lot of my code examples from, but I've been doing this sip of Java where every Monday morning, at least Monday morning for me, I release a new about 1 minute video that covers some new or underused feature within the Java language. And so I've been it's been good for me, been a good way to kind of explore about a lot of new Java features. But a lot of what I'll be covering in this presentation, I've kind of touched on in this sip of Java. And it's both a 1 minute video, and then also I have an accompanied blog article that kind of, gives more detail as well as to the subject of the video. So that can be very helpful as well. All right, so new language features. So the first one we're going to look at is text blocks. This was added in Java 15, and the JEP for it is 378. Now, if you don't know what JEP is, that is JDK Enhancement Proposal. And so whenever a new feature or change to the Java language is being proposed, or not just the Java language, but the whole JDK itself, and it's going to be somewhat substantial, requiring maybe 2 or 3 weeks of work, or in some cases much, much more, it is then put into a JEP, and then that describes the proposal for the change, what's the goal, what are the motivations. But let me bring this up here. But you can find all these JEPs here if you go to OpenJDK, OpenJDK Java.net JEPs 0. That way you can, there we go. So yeah, if you go here, oops, too close. You can then read all about these JEPs, and it can be really good information just to get like really, oops, not the one I wanted. But it gives the motivation, examples, how to use it, and all that. So this can be some really good information. I'm not going to go into detail. There's a lot to go through for each of these different proposals, but I can really explain how this is all used as well. So definitely good links to follow to learn more about a lot of these features I'll be covering. Well, wrong way. There we go. So, but text blocks, I figure when it starts strong, this is one of those easy to grasp and things that will make a lot of lives for Java developers easier. At some point, every person's going to have to work with either XML, JSON, HTML, or some markup or formatted language within their code. And here we just have this really simple JSON message that is just kind of like sending my name and job title and Twitter handle. And it's almost illegible. We have all this formatting for like the new lines and tabs and all that, and having to escape out the quotes and all that. I mean, we can kind of read what's going on here, but this is also a really simple example. And once you get to more complexity, where there's more nesting down, it becomes very difficult. And then, of course, it's also a maintenance nightmare where you can very easily, forget to have a quote or escape it out, or so many different things. And then all of a sudden, you're going to have like a really difficult bug to fix or something like that. So painful, horrible, but now so much nicer and cleaner. So in Java 15, text blocks, they are delimited by these triple quotes at the one line and then triple quotes at the end. And then in here, a lot of the formatting requirements are reduced. So you don't have to declare, yes, I'll share the URL for later. Thanks for asking. Yeah, I'll be sure to do that. I'm guessing that's for the Jeffs. But yeah, so the within here, you don't have to declare new lines. We don't have to escape the single quotes as well. So now this just reads as it would actually then pre-printed out, and then also formatting here. So like this white space, the tabs as well. This is also preserved, and I think I have a link to it as well in here. But there's a really great article, there's by Stuart Marks on the Programmer's Guide to Text Blocks. There's a bunch that kind of goes around with like how they handle incidental white space. So pretty much right here, all the white space here is being ignored, and it's kind of being based upon where this triple quotes is, but it's a little more complex than that. I don't want to go through all of that, but really pretty much it's kind of where you want to put these triple quotes. It kind of gives you where the white space, all of that to the left will then be ignored. So that's probably just a good general practice that this will kind of, work the best way for you, or the most expected way. Of course, also, there's like string formatting where you can kind of give these variables here that can then be passed in. And that just works exactly like it would with a normal string. So, you can still put escape sequences. Like, so if I put like a \n in here, like that should still be rendered as like a new line. You just don't have to do it as much. This will be printed out exactly as it would look here. So it's just much easier to work with. Also though, like let's say in this case, like you maybe have like a really long line that's just going to be printed out as a single line. You can put just a single backspace or backslash like this, and that will ignore the character return. And so this would then be printed out as one single really long line to wherever you're printing it out to. In this case, I'm printing it out to console, but wherever it would be rendered as one single long line. All right, so the next I want to cover is switch expressions. And actually, I'll also make sure to include this link, but my colleague, Jose, I'm not going to butcher his last name, but Jose, he has this thing called Jet Cafe where he just covered switch expressions, and I'll be sure to provide a link to that as well. He gives some really great information about it. But about it, so switch expressions is you still have switch statements, so you can still do like the old or the syntax of case, colon, and then some body to execute. But then now there's switch expressions, and so one change is that, and they're denoted by the little arrow operator, and they'll only execute the code to the right of this arrow operator. There is no follow through by default like there is with case statements where you have to put a break if you don't want to, then execute the subsequent code, which is really nice. Switch expressions can also return a value. So that can also really simplify the code instead of having to put like a bunch of return statements or assignment operators or something like that. You can simply put like the string result, and then based upon which case is being executed, that will return this value of Sunday, Monday, Tuesday, and so on to it. You can also have it execute a block of code just by providing it with the squiggly braces, and that will then allow it to execute a block of code. Now, if you're going to do that and you're returning a value, then that block of code needs to end with the yield statement, or the yield expression to be more correct, that then returns a value. Of course, if you're not returning a value with this expression, that's not needed. And the reason it's yield instead of return is just to prevent some sort of confusion where if you have this within like a method, which of course would really generally be the case, and you had a return here, then it could be kind of confusing if returning out of the method or returning out of the switch expression. So they just used yield instead. And so as we saw in like all these previous examples, I also had a default case. And so switch expressions are required to be exhaustive. And so most of the time that means is you're going to have a default case within your search expression to then, make sure it's actually exhaustive. However, here in this example with like an enum where I have like all the different days of the week, I don't need to have a default case because I am covering all the possible cases here as well. And we'll see also how that plays in with some other new language features here in just a few minutes as well. The next I'm going to cover is pattern matching for instance of. And to maybe give a little bit of where I'm going to be going towards a little bit later, pattern matching is going to be a really big change and concept coming to Java over the next few releases, particularly coming from what's called Project Amber. And that's going to really help reduce a lot of boilerplate and just kind of make, incorporate some of the more modern language features that other languages have also kind of shown off or implemented in recent years as well. So like your old instance of, and I mean, again, this is still completely valid syntax in Java 16 and beyond, but I should say maybe the existing or the previous instance of, you would have like here, like if this object, okay, this actually is a string, and it's like, okay, if actually is a string, it's an instance of string, then we're going to assign it to being, some other variable, a string, and then, work with that variable. And so there's just like a lot of boilerplate in here. And beyond just the boilerplate and having the verbose of having to type this all out, it just creates a bunch of opportunities for this code for bugs to crop up here. Like maybe you forget to assign it or forget to cast it properly, or just a number of different things could happen that could then, just allow bugs to crop up. So we can simplify this to make it a much more easier to read and understand. So instead of having to do a whole separate assignment operation, we can do it all within the instance of. So object actually a string. If actually a string is instead of a string, then we'll assign it to this variable, now I'm a string, and then we can use that. So this now I'm a string, this is what's called Flowscopes. And so if you're not familiar with Flowscope, I really didn't know about it until I started researching pattern matching for instance of. What that means is that now my string will be in scope for wherever this is definitely true. Now, how most we're going to be using it, 99 times out of 100, it's going to just mean it's going to be whatever was within the block of the if statement that you just did this operation in. And we can kind of see this here. So here, there's now a string. It's in scope here. But once we leave the if block, that's no longer in scope. And then here's another example, not that you would really do this, but like you would be testing if instance of a string and then set it here. But then you're just really returning the true false of this. And you can still see that now my string would again be out of scope after running this operation. And then also that would mean then that if it's if you're doing like an R here, by definition, really this would only this R would only be executed if this first parse was false. So this is going to give a false, or this is going to give a compile error because that means now I'm a string wouldn't be in scope here. But of course, an AND operator would work because it would have to evaluate to true before this could be executed. So, okay. So one question just got asked is, switch expressions and pattern matching are already available in other JVM languages, for like example, Scala. So why did Java take this long to implement these features? And that's a great question. So Brian Getz, if you don't know who that is, that he is the language architect of Java. He actually talks about Java, like one advantage having being the quote unquote last mover advantage. So instead of trying to be on the bleeding edge of these of incorporating new language features and programming concepts, we're actually kind of letting other languages, Scala, Kotlin, and of course even non-JVM languages, to try to implement them. And then if they are popular, if they are useful, then we'll then later incorporate them into Java. And there's a lot of advantages with that. For one, I was kind of talking about earlier with, like, for example, switch expressions compared to switch statements. Like, one big issue with switch statements that often developers run into is the fall through by default. That's caused so many bugs, and if it doesn't cause bugs, it's just really annoying having to put that break statement in each switch case statement. So by allowing to see other languages kind of experiment with these features, that can kind of help to allow these features, when they're implemented in Java, to be much more refined. And so that's an advantage. And then also, kind of one of the things that kind of goes with that is, if you've been following the new developments in Java, like, we now do preview features. So for example, this pattern matching, it was released as a normal feature, or as a production feature, I guess you'd say, with Java 16, but it had 2 previous rounds of preview feature status in Java 15 and Java 14. And that also allows any sort of kinks or issues to be kind of worked out, or if something needs to really be just completely redone, like, for example, was the case with text blocks. Initially, I think there was a proposal for, like, quote unquote, what was called at the time raw strings in Java 12, I think. And that a proposal was eventually withdrawn, and then we eventually got what is now switch expressions, or not switch expression, text blocks as well. So that way, it's just going to get it to be where the features that are being added to Java are going to be much more refined, much more developer friendly, and there's not going to be those weird quirks that can sometimes crop up, which I'll also touch on a bit more later on some other features that have been implemented in Java that didn't work that well. Then another question is pattern matching the step towards destructuring? And yes, absolutely. I won't necessarily talk too much about that, but that is actually something that's going to be coming very soon. I think the first one, I'm trying to think if there's a preview feature for Java 18 where we have that for records to be able to destructure them. I think that is, and if it's not Java 18, it's going to be probably like Java 19 or Java 20 when that's going to be first added as a feature as well. So yeah, that's another big thing that's going to be coming to Java in some of the upcoming releases. Great questions, and please keep them coming. Again, it tells me that you're listening, but then also, most of all, I'm here to share with you and let you know about what's coming in Java. So definitely, please ask you questions. Keep asking questions. So just to kind of finish them up here for pattern matching, for instance, and then with the Flowscope stuff. Again, not that you should really ever do any of these things, but here in this example, instead of like with this if statement, I did a not around this. And so, of course, then within here, now I'm a string, wouldn't be in scope, but then it would be in scope in the else. And if I wanted to be really kind of wacky with this, I could put this as a not within here, throw an exception if it's, this isn't a string, but then have it be available outside of it. Not that I would recommend doing any of these things, but this just kind of gives you an idea around how Flowscope kind of works and how it's kind of a bit different, but it, like I said, 99 times out of 100, how we're going to be using 99 times out of 100, this is just how we're going to be using it. We're going to be using now a string, and you just need to assign it to some sort of other variable that's going to be in the proper scope you want to use it for later. Actually, I think I have that example here at the end. Yeah. So yeah, that's just 99 times out of 100. This is really probably what you're going to be really doing with it. It's just something that looks exactly like this. All right, so the next thing, sealed classes. These are one of the things that's actually coming in Java 17. Oh, and I guess one quick thing. So we're getting really close to the GA for Java 17. The first release candidate was released like a week or two ago. And if you follow the road path on the Java releases, so like we released the release candidate 1 on the expected dates, and there hasn't been a release candidate 2, and that's just because there hasn't been a need for one. There hasn't been any issues found or any meaningful issues found in the first release candidate proposed. So unless some huge issue comes up or something, there's not going to be a release candidate 2, and so the release candidate 1 that's available now is what's going to be then the what's going to be available here on September 14th when Java 17 is officially released. So sealed classes, I've been having like difficulty kind of coming up with like a good example for this, and so I kind of decided to go with this like example of like tree of life or something, and I use this because what sealed classes allow you to do is kind of define what a class, like how many subclasses could be implementing or extending off of a class. And so here we can see like, okay, this tree of life, like there's going to be 3 major kingdoms, available, or, eukaryote, archaea, bacteria, and then they could branch off into other ones. And then, there could be still limits within these onto how much differences there could be as well. And so with sealed classes, what you do is like this dashes, these dots, and these hard lines all kind of refer to different types of classes. So like this life class, it's a sealed class, and then within it, and I'll show the code here in a moment, I say only bacteria, archaea, and eukaryota can extend off of it. And then bacteria, okay, it's also going to be a sealed class, and it's going to say only cyanobacteria can extend off of it. And then cyanobacteria is a final class, so then nothing can extend off of it. Eukaryota, like it's just going to be like a normal non-sealed open class, and then that means it can just works more or less like a normal class, and then a bunch of stuff can just, it can have any number of things extending off of it. Animal here, like it's a sealed class, and it could be either non-notochord, so something that doesn't have like a spinal cord, or a notochord, something that does have a spinal cord or a nervous system. And it's going to be a sealed class, and it can only kind of have a limit to how much it can extend off of it. So, I thought I had here. Let me actually show some code examples of that. I thought I had a code example for that, but to actually contextualize this. So what this all looks like here is I would have like this, and like this in this case, let me make that a lot bigger. So yeah, there's new keywords like sealed and permits. So here I have life, and I have it permits to have bacteria, archaea, or eukaryota to extend upon it. And thanks for the compliment. And then it also just declares one field of of name. And then from here, like archaea, it's going to be a non-sealed class, and so that means it can just also allow for anything. It just unseals it and then allows anything to kind of extend off of archaea. I think then bacteria, it also continues to be a sealed class, and it permits cyanobacteria. So what's nice about this is that oftentimes, like what you could have is like maybe you have certain kind of domain concepts within your code. Like maybe there's can only be a certain amount of account types. Like you could have like an admin, you could have like a user, you could have like a super user or something like that. But like you don't want to have any other types of user types or something like that. You can kind of like actually limit that, or it could be like if you're working in finance, like you may have like certain kinds of different financial types, like a brokerage or like a non-brokerage and things like that. Like at every organization I kind of worked at before becoming a developer advocate, like we would have like all these kind of certain domain concepts to where there was like a specific limit to how many of these different concepts there would be. And that could be where it could be really useful to have a sealed class, is to say like you have like whatever your super type is, and then there are only 2 or 3 or however many different subtypes that could really be by it. But what's also nice with sealed class is that it doesn't dictate for those subclasses what they can do. Like those subclasses can also have like evolve in their own way as well. Yeah, exactly. So that's kind of why I decided to do that tree of life example, just because things kind of continue to branch out. Like there's like these 3 major branches, and then these things can kind of all continue to branch out as well. And that's kind of what sealed classes allow as well. To go back to a previous thing, though, with switch expressions and how some of these features are building upon one another, I was talking about how things have to be exhaustive with switch expressions. And here, because only archaea, bacteria, and eukaryota are the only things that can extend off of or be a type of life, I don't have to have a default case here. The compiler can understand and read that definition within sealed class and know that there's not going to be any other possible type within here. So that could be something then that can be beneficial with using sealed classes, is that you can then have more concise other language structures within it, because the Java compiler can actually read and understand what's being defined with the sealed class. And so like here again, it can know that you don't need a default case. All right, so I think, this is the last new language feature I'll be talking about. Last but definitely not least is records, and that's going to be JEP 395. That was added in Java 16, and really, as records, I think it's going to be one of the biggest new language features, probably since Lambdas, to be added to the language. And that's going to be kind of coming also in things with like destructuring and the other pattern matching that's going to be built upon records. That's going to really probably simplify our code and address a lot of painful issues within the Java language itself, or within Java as well, which I'll touch on here in just a few moments. But the most ready way that records is beneficial, Braven makes a great point that, backwards compatibility is absolutely key when it comes to Java, making sure that, there's an enormous amount of code already written in Java, and making sure that all that code can still run on newer versions with relatively few changes is absolutely key. So like that also is one of the things that the Java language architects consider as they're adding new features, just to make sure that they're backwards compatible, or, kind of like why we have switch expressions have the error operator instead of, changing switch statements themselves. So back to records. So the most ready and obvious way that records are beneficial is, like, let's say I just need to declare like a simple person class to hold some information. Even for something that just has 4 fields, like it's a whole lot of code. We had to have the hash code, equals, toString, the constructor, and all of that. And if I declare this within like the body of a method, it becomes almost unreadable to the method. Like, it would just be so confusing to read this, and it breaks up all the flow. So all what this is can be declared within just a single line with record person. And that will give you a canonical constructor that matches the components you declared here within record, accessors, hash code, toString, and equals, and all that will be all done in just single line. And so that makes things much more readable. So some things to keep in mind with records is, so the purpose of them is to be a transparent modeling of data as data. And the superclass of records is always going to be Java lang record instead of like it is with most classes, which would be Java lang.object, which would be, its eventual superclass. I mean, that would still be the case of records, but here with like this person class here, like the superclass for it would be Java lang object, but now it's Java lang record. And so that can obviously then allow both frameworks and then of course the JDK itself to know specifically that anything that's declared as a record is in fact a record and not some other kind of class. So records cannot be records. Records I think are definitely going to be the coolest feature I'm looking for. Which feature our modern feature I'm looking forward to most or enjoying the most is records. There's a lot, as I learn more about it, there's a lot of stuff going on there that addresses a lot of issues within the language as well, particularly when it comes to serialization. And I'll make sure to kind of get to that at the end when I go kind of cover some code examples, because I'm actually doing some work with that right now. But so records can't be extended. They can't be abstract, and they are also implicitly final. All their fields are final as well, but it's only shallowly immutable. So like, let's say one of the fields in my record is a list. You can still, like, you can't change the list. Like you can't like change the reference to which list you're using, but you could add or remove elements from that list. Like records isn't going to stop that. It doesn't enforce immutability down to that level. You can't declare instance fields, as I mentioned already, just so that accessors, hash code, and two-string equals are all automatically generated. But you can also provide your own default implementation, or you can override those implementations as well. So kind of what I mean by that, like let's say with this two-string, instead of having like the normal like square bracket, field equals this, field equals that with two-string, like I can just change it up to where I have like a more formatted kind of two-string that kind of prints it out in some more human readable format. And then also I can just add my own method like to JSON for if I wanted to print out JSON using records. So I'm gonna, I'll return at the end. I want to cover a key thing about records and one of the big issues in Java, which is serialization. But I want to get through some of these other features or the other changes first, and then we can go back to that. But definitely, if I forgetting to get back to that, someone please mention that. I do want to cover that later on. But let's get into some of the new runtime features and enhancements. So one of them is the CVS updates, and that's that stands for class data sharing. And so in JDK 12, what was added was a default CDS archive, and JDK 13 is a dynamic CDS archive. And so what this allows is for a faster startup. So whenever the JDK or whenever the JVM starts up, it's going to always load certain core classes that are just, the core of the JDK. And that's going to be the same for every JDK or every JVM that starts up. So the default CDS archive provides a pre-processed archive of all those classes that then can be memory mapped by the JVM. And then if you have multiple JVM processes running on the same host, they can all reference the same memory location, which, again, only if you're running multiple JVMs on the same host can save some memory. Also, what was added is what's called app CDS, and I think that was first introduced in Java 10, but then now made much easier with Java 13 with dynamic CDS archive. So the default was only for core JDK classes, for Hello World or something like a really simple application like that, it would somewhat improve the startup time. But by the time you get to like an application of any sort of, real complexity, you wouldn't really notice too much of a difference in startup speed. But app CDS allows you to also create a pre-processed archive for your actual application classes itself. And then that can actually notice a pretty noticeable improvement in your setup speed. So to do that, you would do like archive classes as exit, and then you would give like the name of the archive that you're creating. So I'm just a generic dynamic archive, and then the application you're going to execute. And then the next time you want to run it, you just add the JVM argument, shared archive file, and then the archive that you created. And I can't remember, but like I thought I had some examples here, but it's about like maybe when I was using the Spring Clinic, the Spring Boot Pet Clinic uh, test application, like it took off about like 20 to 30% from the startup speed. So it's not trivial as far as the improvement in startup speed can go. And also a lot of this stuff is like, let's say you're using a lot of Spring Boot or Quarkus or Jakarta EE, Micronaut, let's just say at your organization, you kind of decided on one kind of tech stack to kind of use. Really, you wouldn't have to go through and create a shared archive for each application, because overwhelmingly what your application is going to be is the underlying libraries, like whatever your frameworks you're using, again, Spring Boot, Micronaut, Jakarta, stuff like that. So you can just create one shared archive for whatever kind of text that you're using, and you should really be able to use that then for all your other applications to get 90%, 99% of that benefit, just because, again, most of the archive is being built up based upon your underlying framework application. And I think I do have some examples on kind of how to go into more depth with that. I think on my Sip of Java. So also, we added a new garbage collector, ZGC, and Z doesn't stand for anything, or Z doesn't stand for anything. It's just the letter they chose to use. It's complete redesign of garbage collection on Java. Right now, ZGC is just a single generation garbage collector, as opposed to other garbage collectors like G1, Serial, and so on. Those are what's called generational garbage collectors, where newly created objects reside in like a new generation. And after a certain number of times where they maybe survive a garbage collection, they graduate to an older generation where they aren't checked as often. Right now, ZGC is all single generation, but it still offers really incredible performance. It tries to keep pause times under 10 milliseconds, which is extremely fast. It's all scalable, so it can handle up to multi-terabyte heaps. And you can try it out. So you can just, and right now the default garbage collector is G1, but you can just say use ZGC. You can set the heap size to whatever you want. I mean, it can go to multi-terabyte, and it gets more efficient, I think, the larger you get it. But it could still work at these sizes that like you're more, used to, of like maybe about a gigabyte or, have a meg or so. And then you can turn on GC logging to kind of really get an idea of what it's actually doing within your application. This one, I think, again, every Java developer is going to be very excited for. Helpful null pointer exceptions. We've all run into them where, you have like some line where a null pointer is thrown, and it could be any one of like 3 or 4 different things. And you have to put like, that debug statement in here in your code, and then redeploy it to finally track down what's actually throwing the NPE. But now you'll actually get like a helpful exception. So, and you don't have to even recompile your code or any of this stuff. Like for all these runtime improvements, you don't have to recompile your code. You can take your existing code, and as long as there isn't any other underlying incompatibilities, it could actually work with this new code, or with and take advantage of these new runtime features. In many ways, it will give you back like saying like string length, it failed because the variable it was trying to do that off of was null itself. So yeah, that's just going to be a big improvement for anyone whenever you run into those NPEs. ARM architecture for 64 is being more supported. So Linux all the way back in JDK 9, Windows JDK 16, and of course Mac OS now that they have like their M1s, which unfortunately isn't what I have for my laptop. That has been added. That will be provided in Java 17. Also, so with every release of Java, there's always going to just be continual improvements to the JVM itself. And I kind of ran an example. In this case, I didn't use Java 17 when I was doing that because it wasn't, this was a few months ago. But it can be pretty substantial improvements. So like, and again, I'm using the Spring Boot Pet Clinic test application, but the exact same binary. I built it with Java 8, and then I ran it in Java 8 and then Java 16. And we can see like the startup time is much faster. The throughput is a little bit faster, but use just really a lot of the memory. Like I kind of really constrained it, but like usually like the memory usage is much better anyways. Like if I didn't really set the memory heap space, Java 8 was using like about twice as much memory as Java 16. But yeah, every release of Java, just small improvements are being made to the JVM that can, have they can start to really add up over subsequent releases. All right, the last section is going to be deprecation removals and other changes to know about. Sorry, kind of goes back and forth. My mouse, like if I just like tap it, like it tells it to go back, and it's just, I really need to turn that off or something. So deprecations, security manager, what is being deprecated for removal in Java 17. I'm guessing most people here haven't used security manager. Every time I ask, like almost no one uses it. Now this might sound like Java is becoming less secure by removing the security manager, but the fact that probably many of you haven't really used it kind of tells you that it's not really something that's being used much. In the end, really, most of what security manager does can just be handled by OS level configurations. So like if you don't want it to be calling like any URL outside of like your organization's network, you can just set that at the OS level or have it to where it can't access certain file directories. Again, that could be set at the OS level. Security manager, it just in the end, the complexity of actually trying to use it was just so much that most people just didn't use it. And then there's just a big cost to it on our side to continue to maintain it. So we're going to end up being removed. It's an ongoing discussion on exactly what that's going to look like, just because there are some things out there that do kind of still depend upon some of this API. So if you are maybe still kind of using it, how it's going to be removed, how it's going to kind of maybe some of that underlying API going to be supported is something that's going to still be kind of ongoing. The applet API, it's being marked for removal with JDK 17. I think all the way back in JDK 9, it was deprecated. So, applets aren't really used anymore. If that's what you're still dependent on, you're going to have to kind of find something else, maybe. Things have been removed. Nashorn, the JavaScript engine within the JDK or JVM, that was removed in Java 15. The CMS garbage collector was also removed, and that was really just kind of usurped by the G1 garbage collector, which was then made the default garbage collector in Java 9. So if you're using CMS, just use G1. That offers very similar behavior and performance, or actually improved performance over CMS. And then the last somewhat major change is they're going to be strongly encapsulating JDK internals with Java 17. And that's this part of the continued thing that started with the introduction of the Java module system back in Java 9 on improving the encapsulation of, key JDK internals. So there's no longer a single argument illegal access permit that can allow this like a blanket opening up of reflection internals. Several critical APIs, though, are still available, like Signal Handler. By far, the biggest one would be Sun, Mist, Unsafe, and just all these other ones as well. Eventually, illegal access permit will be removed. So like right now in Java 17, if you put that JVM arg in there, it's just a no op. Thank you, Mala. Right now it's just a no op, but eventually that will throw an error at some future portion. And of course, also, if you do need to get into some sort of module or something because some library or your own code depends upon it, you can still do the add opens as a JVM arg or as a jar manifest file if you really need that. So it's not like going to be a complete roadblock, but it is going to be increasing the pain for frameworks and stuff that do depend upon reflection. Thank you, Mala. Yeah, thanks for joining. No problem. All right, so a brief look into the future of Java as well. So as someone mentioned or was asking, when it comes to like the pattern matching and destructuring. So let's see. So in Java 17, pattern matching for switch, this will be a preview feature. So preview features, like you have to do a bunch of, like you had to do like a flag at compile time and at runtime to be able to use them. So like they're not really supposed to be used in production. But you can see here we can have like guarded, like you can add like guards to your switch statements to where instead of having to put like a triangle and then within like this case to put like, okay, if it's under or if it's over 100 feet, then it's a large triangle. And if it's under, it's a small triangle. You can actually declare that within the switch expression declaration itself. And then also record patterns and array patterns. Did I? Yeah. Okay. Yeah, I do have an example of that. That's also coming in Java 18 as a preview feature. And actually, I ran into an issue where like was doing some examples where this would have been extremely helpful. But you can just directly reference the values from within like the members within an array directly instead of having to do the referencing like its position within the array. So that will be much easier. And I think I don't know if it was added in. It's also going to be coming in Java 18, but maybe in some future release there is also ones where destructuring records is going to be added as well. But yeah, here's like another example of also of record pattern matching. Oh yeah, this is for the destructuring, I think, of it, which is just going to be very nice to have in upcoming releases. So it's just a good example of how a lot of these things are just going to be building upon one another. There's going to be even more stuff, more pattern matching for sealed classes, more should be destructuring patterns and deconstruction patterns as well coming. And you should definitely check out this article by Brian Getz, which really kind of lays out the path for a lot of this pattern matching and what's coming in Project Amber over the next few releases of Java. The order access builds are always available. So you can get it for Java 17 here, Java 18, and then there's several other projects. So like there's Loom, Panama, Valhalla, which are more long-running projects that are adding new features. Like Loom is adding virtual threads, which is going to be a huge change to Java or a huge improvement to Java when it is eventually incorporated into the mainline build at some point. So you can check that out here. I get Panama and Valhalla. I can't always remember which is which, but one is for value types. I think Valhalla is for value types, which is going to be a big improvement as well when it's added. And Panama is for native library access, which again it will kind of really help improve the JNI features as well if you're using them again when it's also incorporated into mainline. And some of these features, within these are being added piecemeal. It's not like it's all going to be one big thing that's going to be added in one single big clump for these. Some of them will be small features being added. I know a few things from Valhalla has been added to upcoming releases of Java as well. All right, so code examples, you can see all these here, and I'll be sure to get this. Let me go ahead and get this link into the chat, just so everyone has access to it. Oops, give me, there we go. One moment. There we go. So I just posted the link to my presentation into the chat, so you have that there. Also, be sure to give it to the jug leaders as well, so they can share it as well. But one thing I wanted to touch on that was promising is, so this is also kind of going back to the quote unquote last mover advantage of Java, and this is so. One thing I've been kind of working on recently is about serialization in Java. And it's one of those, it should show up here in just a moment. I thought I posted it. I wonder why. I thought I posted it in there. I'm not seeing my own post. Okay, there it is. There we go. It is there now. Sorry. Or is it? Okay, I'm not sure. I thought I posted it into the chat. I'm not seeing my own thing come up here. I'll make sure that my link gets shared out as well, though. I'm not sure why that's not showing up. But real quick, so serialization is a really sticky issue within Java. And we can kind of see here some of the potential issues with it. Let's see if I hopefully have everything in a good and ready state. So like, let's say I have this simple message class, which just contains a message. And you can see here, like I have this the single public constructor, which is going to check to make sure that the message is not null, and it's also not empty. And if it is, then it will throw an exception. And then to even make sure that this is the only way to instantiate the class, I even have it. I set the default constructor to be private, and if you try to call it, it will throw an exception. All right. So if I start this class up, yeah, that looks to be all right. So if I start this, and then I go in here, and if I go ahead and then comment that out. So if I comment this out to where I can then pass into null. Oh, no. There we go. Let me expand that a bit. So yeah, I'm going to pass this to null. And what's happening here then is it's going to send this as a message and serialize this message class, and then send it here to this serialization class, or this server class, to then deserialize it. And so the message class that this is using is the one that I had set up before, where it should not be possible for messages to be null, but we're going to see here really soon that it can be null. If I run this class now, I'm going to get a null pointer exception. Okay, of course I don't. One moment, I thought I had it set up correctly. Oh, okay, that's why. There you go. Sorry about that. I didn't have it set up correctly. So this version of message class that class serialization is using when I started up, it should not be possible to provide a null message value, because like this will throw an exception if it is, and there's no other way to set it as well. So again, if I start it up, and one more time. And now I send this. Okay, well, that's not the. Sorry, that one of the problems of live demos is sometimes they just refuse to work with you. But one of the big issues, what really should be happening here, and I won't spend too much time trying to figure out why it's not working right now, is that serialization is able to break a lot of encapsulation. So when this class is being deserialized, instead of like trying to call the constructors for this class itself, like serialization will instantiate it kind of like through its own magic, and then reflectively set like the message field. And that will, even though we want to have this checking to make sure a message can never be null, they could actually get around that with serialization. A much more potentially serious issue also is you can inject code with serialization as well. So here in this little quote unquote exploit class, like I have like a runnable class that's serializable. And then so serialization works upon some of these quote unquote magic methods, one of them being read object. And if I implement that myself, I can kind of tell it to do some funny stuff. Like in this example, I want to have it to do run this injected code. And hopefully this time this will work to at least show what I'm talking about. Okay, sorry. Sorry, my example isn't working right now. I don't know why I'm getting this invalid stream header, but really what should be happening is this exploit code, which in this case, of course, is just printing out a simple message, would be executed, even though that's not really at all what would want to be happening. And even though within this, I'm really not even expecting this kind of class back, the exploit class that I was kind of referring to, it would still be deserialized and allow an error to occur. So our potential exploit to be done onto my application. So what records does is that the way it handles serialization is it actually has to go through like the constructor of the record and not through like these read objects and all that stuff. So that resolves, and it doesn't do, like the fields aren't set reflectively either. So that resolves or prevents a lot of the major issues from serialization happening. Sorry, my code example isn't working. I've been kind of doing some work on it, and obviously it wasn't in a good state when I left the last time. But when you're doing any sort of serialization, when you're reading in values from like an external client, it could be really good to consider switching to records instead of just using normal Java classes for security reasons, and then also to make sure that things like encapsulation aren't being broken as well. So sorry that code example didn't work that well. I'll have to update it, and I'll kind of share that with the Jug leaders here as well, so you can kind of check that out, because it is actually kind of like a really important issue. Kind of with that said, I think that is the end of the presentation. If you have any questions, I'll be more than happy to answer them now. Yeah, and also I think so. Popular frameworks have already support for Java 11. I think actually many are actually keeping pretty good with keeping up with the current release cadence of Java languages. Like I think like Java or Spring works with Java 16, and I know they're working on getting Java 17. Okay, thank you. And yeah, that must be what links sometimes won't come in on YouTube. So yeah, that's what's happening with mine. Unfortunately, I'll make sure that gets sent out. But yeah, a lot of frameworks, a lot of underlying tools are actually pretty good. That's like one of the nice things also about the more regular release cadence is the differences between each individual version of Java is relatively small. So supporting the next version isn't too difficult. And because it's like a very consistent release cadence, frameworks and tools and libraries, they can all kind of have a pretty good idea of like, okay, Java 17 is going to be released on September 14th. Java 18 is going to be released sometime like September or March 13th or 14th or something like that of 2022. So like that's pretty consistent as well. So that helps a lot when it comes to library and tool support. All right. No more questions. Thank you, everyone, for coming and seeing my presentation. And like I said, we'll make sure I'll get the links sent out so you can get to all the other links and the code examples as well.
Sure. Thank you, Billy. Thanks for your time and awesome explanation. I would also like to thank everyone who joined, and they asked questions and you answered them on the fly. So thanks for that. So yeah, once you share those links, I will just drop them in the mail via the Jug link.
Yeah, I'm sharing with them in the private chat with us, which no one else can see here.
Yeah.
So, and you can get that then sent out to everyone else. So yeah, those are the two key links to share.
Yeah.
So yeah.
I
All
got
right.
it.
Thank you, everyone.
Thank
Great.
you.
All right. Bye.